So before we get into our equations for quadratics, we need to talk about complex numbers, okay? Maybe call it imaginary numbers. We need to get real solid on them. What is a real number? Does anybody know what is a real number? A whole number is a real number. So a whole number is like 1, 2, 4, right? Okay. What about 6.7? Is that a real number? It's real. Okay, so the whole number wasn't quite the best definition. This is sort of hard to define. It's like, in English, you're not, if you're told to define what does it mean to be scary, you don't say like, well, when you're scared. You don't use the word. So you're trying not to use the word real, and you're trying to define a real number. It's what? A definite. What do you mean by definite number? It could be negative, right? Any number. So any number. What about I? It is a number. It's a complex number. So we haven't gotten there. Anyway, I'm just toying with you. A real number is any number. So it's any number. Any number that can be expressed as a distance on a number line. Okay, so like the number 2, that could be a distance on a number line. I'm 2 units away from 0. What about the number pi? Yeah, I can be about 3.14 units away. Okay, what about the square root of 7? Yeah, that's a number. Okay, these are numbers that are real, so it can be expressed as a distance. So it could be, -6 is 6 units away, so that's a real number. So these can be positive or negative. So that's what a real number is. Now, what we need to talk about today are complex numbers, and you may not have seen this before. Okay, so we're going to talk about complex and the complex number systems, and then we'll need to talk about how do we add and subtract complex numbers. How do we multiply complex numbers? How do we have a complex number and we raise it with an exponent, raise it to a power? And then what we'll do when I see you on the block day, how do we divide complex numbers? Okay, so this is our basis for the quadratics, because complex numbers will naturally occur when you're dealing with quadratics. We just need to be solid on them right now. So everything we're going to do with complex numbers is based on the definition of what the square root of -1 is. So square root of -1, what have you been taught so far? What? So, okay, then what's the square root of -1? What? I. Okay, but you may have been taught you can't take the square root of a negative number, right? Right. So that's what we're going to do today. We're talking about complex imaginary numbers. You may have been told like, oh, you can't take the square root of a negative number. What we really mean is the square root of a negative number is not real. Okay, there is no real number that I can square and get a -1. Because when you square any number, if it's a negative number you square it, you're going to get a negative times a negative. If it's a positive number you square it, you're going to get a positive times a positive. So there is no real number you can square and get a negative number. So, pardon me? Yeah, it's not real is the technical definition. So it is defined, but this is not a real number. So this is not real. But we need to go forward with the definition and see how do we work with the square root of -1. So we call these complex numbers. They also are called imaginary numbers. They were called imaginary because when people first started working with them, it did not make sense, okay? Because you think of numbers that you can count. I give you $4. I can't give you an imaginary $3 dollars, so it doesn't make sense. It's not real. Most of the stuff that we deal with complex numbers came around the 1500s. It's sort of shocking, but everything we do in this class was pretty much known in the 1600s. So Algebra 2 has been around for quite a while. And it may just feel like we're making stuff up when we deal with complex numbers, but if you were to study circuits and electricity, none of this would not be possible without imaginary numbers. Okay, so it has real applications for signal processing and for electronics. Now, you've got to know this definition. Everything we do with complex numbers is based on that definition. So we're going to say that the square root of -1, I know it's not a real number, but I'm going to just say we're going to call that, we're going to call it I. That is a number. So that is our definition. I is the square root of -1. And then everything we do will be based on that. I had a kid last year. I said, like square root of -1. I said, what is square root of -1? He said, according to you, it's I. So I mean, if you feel like that helps you remember, that's fine. But it's not just according to me. This is our definition, that I is the square root of -1. So let's work with that and see what we come up with. So some baby steps. What's the square root of 4? 2. Okay. No problem with that. Now let's look at the square root of -4. So the square root of -4, that's the same as the square root of -1 times 4. Does everyone agree with that? Okay. So now tell me what the square root of -4. What is the square root of -1? I. That's our definition. Okay. And then what's the square root of 4? 2. So this is I times 2, or we will write this as 2I. Okay. So the square root of -4 is 2I. Because the square root of 4 is 2, the square root of -1 by definition is I. So this is 2I. Square root of 25 is what? 5. Okay, so you see this. I've got 5. That is the square root of 25. Okay, so if you square this number, what do you get? You get the number that is right there. Okay, so 5I is the square root of what number? Yeah, -25. So if I had -25, 5I is the square root of that, because the square root of -25, that's the square root of -1 times 25. You don't have to write this out every time. So that's just going to be 5I. The square root of 25 is 5. The square root of -1 by definition is I. What about this one? This is the square root of what? So I'm going to write this as the square root of a real number. $25. So the square root of 25. So the square root of 25 is what? So this is the square root. This is the square root of, sorry, let me back up. Make sure I get this correct, guys. Sorry, this is the square root of -25. That's 5I, okay? What is this one? This is the square root of what? Square root of 25 is what? 5. Is that -5I? No. How do I get a -5I? Pardon me? 25I. No. Okay. What's the square root of -25? We just established that. 5I. What am I trying to get here? -5I, right? Okay. What would this give me? 5I. How do you think I get -5I? Like that. Okay. Negative square root of -25. So this is negative the square root of -1 times 25, which is -5I. Okay. So your head will spin a little bit on some of these things. Okay. You just got to be comfortable working the algebra. I is a number, but we deal with it algebraically just like we would a variable x. Okay. So a complex number is a number that can be written in this form, a plus bi, where a and b are real numbers. And I, by definition, is always the square root of -1. So if we have a complex number, z is equal to a plus bi, we're going to say that a is the real part, and the imaginary part is bi. So if I look at these definitions or examples of complex numbers, what is the real part of this complex number? 5. What's the imaginary part? 7i. Okay. Real part? 4. Yeah. -3i. What's the real part? Somebody said it. Who said 0? 0. Okay, this is 0 plus 8i. So the real part is 0. Imaginary part is 8i. Okay, 16. What's the real part? 16. What's the imaginary part? 0, because this is 16 plus 0i. Okay. And then what is the real part of the next one? Pi. Imaginary part? Negative pi I. Okay. So those are what complex numbers, how they're written. So let's do a few things with them. We need to add some complex numbers. So what we're going to find when we add these numbers, this complex number I is going to work just like a variable, but it is not a variable. What is I? I is what? By definition, what is it? Square root of negative 1. It is a number, okay? So if I had something like 2x plus 3x, you have no problem saying that is 5x, okay? Same thing's going to happen with this. 2i plus 3i is going to be 5i. You treat it just like it's a variable, but it's not a variable. It is a number. So let's add some numbers together. If I were to add this complex number, a plus bi plus c plus di, what do you think you do? How do you add those numbers? What do you think you would do? You would combine what? Combine the real parts and then combine the imaginary parts, okay? So without me giving you the definition, I think you would have sort of guessed that. So to add these two numbers together, this is going to be 3 plus 6 plus 2i minus 5i. I'm going to combine the real parts and the imaginary parts. So what happens when I get 3 plus 6? That is 9. What is 2i minus 5i? Minus 3i. Okay? So all I did was combine the real parts and the imaginary parts. So when you add these two complex numbers, you get 9 minus 3i. And this is written in the form a plus bi. You want your numbers to be written in a real part plus an imaginary part. Okay? What about this one? So what I get, 3 minus 6 is what? Negative 3. And what is 2i minus negative 5i? Plus 7i. Okay? So I added the real parts, 3 minus 6, and then I combined the imaginary parts, 2 minus negative 5 is 7i. Okay, what about the next one? Now, what may help you with this is just to gather like terms. Let's gather all the real parts. So the real parts are going to be what? 2, what? Minus 5 plus 1. And then the imaginary parts are going to be what? 3i plus 4i. So what happens when you combine all the real parts here? 2 minus 5 is what? Negative 3. Negative 3 plus 1 is negative 2. And when you combine the imaginary parts, you get 7i. Okay. Now, what do you think I do in the next one? Yeah, you're going to distribute. So just use rules that you already know. This is going to be 1 plus I plus, what happens when I distribute? What do I get here? 6 minus 2i. Okay. So what are the real parts combined to give us what? 7. 7 minus I. Okay. Is this straightforward? Is this, yeah. Like I said, if I just made these x's, we call this elementary algebra 1. Okay. Only thing is these are i's, so we're dealing with the algebra, but we'll get a little bit more complicated when we deal with the definition of what the imaginary number can do. So that's adding. How much harder do you think it'd be to subtract? Yeah. Is that what I do next? Well, no, I don't. Well, let me just do one. The only thing you have to be careful with subtracting is the distributing out. So, for example, if I had, 1 minus 6i minus 2 minus 4i. If I had something like this, what is 1 minus 2? That's negative 1. What is minus 6 minus negative 4i? Minus 2i. and that's it. So negative 1 minus 2i. If you have trouble seeing that, you can just distribute. This is what? 1 minus 6i minus 2 plus 4i, and then you'll see that this is what? Negative 1 minus 2i. Okay, so pretty straightforward. Now you want to pay close attention to this. This is not, I hate to say things are easier, not that difficult. This is fairly straightforward, but there are people who will struggle with this as what I've seen from the past. So we need to talk about what it means to raise I to a power. Okay, what is I again? Square root of negative 1. So by definition, I is the square root of negative 1. Okay, so I squared, we want to square I. Okay, so I squared is going to be the square root of negative 1 times the square root of negative 1. Does everyone agree with that? That's just I times I. Okay. What happens when you take the square root of a number times the square root of that same number? Yeah. The square root of 5 times the square root of 5 is 5. Square root of 7 times the square root of 7 is 7. So the square root of negative 1 times the square root of negative 1 should be what? Negative 1. Okay. So I squared is negative 1. It makes sense. If I is the square root of negative 1, then when you square that, I squared should just be negative 1. Okay? Is everyone okay with that? Okay. So this was my definition, and then what you're going to see is these powers of I are just going to fall out of that definition. Okay, so I squared is negative 1. Now let's figure out what I cubed is. What about if I write I cubed is equal to I squared times I? Is that true? Should be true. I cubed is I squared times I. Okay. What is I squared? Negative 1. So this is negative 1 times I. What is that? What's negative 1 times I? Yeah, well, it's just negative I. I want all my answers to be in terms of I here, okay? So by definition, I is the square root of negative 1. So I is equal to I. Okay, I to the first power. This is I to the first power. Okay. I squared, that's what happens when you get I times I. Well, I is the square root of negative 1. So negative 1, square root of negative 1 times square root of negative 1 is negative 1. I cubed can be written as I squared times I. Remember, I squared is negative 1, so that just gives me negative I. Let's look at I to the fourth. I to the fourth, does everyone agree that can be written as I squared times I squared, right? Okay? You agree with that? Okay. What's I squared? Yeah, this is negative 1 times negative 1. What is that number? 1. Okay. Let's figure out what I to the fifth is. Okay. So I to the fifth. I to the fifth. I can write this as I to the fourth times I, right? Everyone agree with that? What's I to the fourth? We just figured that out. Okay, this is 1 times I, which is what? I. Now let's move on to I to the sixth. I to the sixth, I can write that as like I to the fourth times I squared. Okay. Everyone agree with that? What's I to the fourth? 1. What's I squared? Negative 1. What's 1 times negative 1? Do you see anything happening over there on the right side? Yeah, so it looks like I'm getting I, negative 1, negative I, 1. I, negative 1. What do you think is next? Negative I. So let's try that. I to the seventh. I to the seventh can be written as I to the fourth times I cubed. All right. What's I to the fourth? 1. What's I cubed? Negative I. So this is what? Negative I. What do you think I to the eighth is? What do you think? 1. I to the eighth can be written as I to the fourth times I to the fourth. I to the fourth is 1, okay? So this is just 1 times 1, that's 1, okay? So when you take I to a power, you're going to get one of 4 answers. I, negative I, 1, or negative 1, okay? So I to the 9th, okay? What we would typically do is, this is where I'm going to arrange it. I to the 9th, how many different possibilities am I getting there? How many possible answers? There are 4 answers. So let's look at 9. What is 9 divided by 4? That's what, 2 1/4, right? Okay. So I'm going to write this as, I'm going to write it as I to the 4th. That's I to what power? 8th. So that's this, okay? So I to the 9th can be written as I to the 4th times I to the 4th times I. The reason I like I to the 4th, what is I to the 4th? 1. So this just turns into, this is 1 squared times I, which is 1 times I, which is I, okay? So if you can organize things in powers of 4, it makes these things real easy to organize. Let's look at I to the 10th, okay? This is what? If I organize it as 4, that's I to the 4th times I to the 4th. How many is that? That's 8. How many more do I need? Yeah. So what's I to the 4th? 1. This is 1 times what is I squared? I squared is negative 1. So that's just negative 1, okay? Please don't ever miss I squared being negative 1. If you were to look up there of the 17 equations that have changed the world, it's number 5. So you have no reason of missing that one on a test. I squared is negative 1, okay? What's the definition of I again? Square root of negative 1, okay? So you don't have to memorize this stuff, you know, I to the 9th or I to the 12th. You should be able, like I did, I worked all of that out. Now, what you're going to see some bigger things. What is I to the 17th? I don't want to sit down and write 17 different rows of information to figure this out, okay? So let's divide 17 by 4. So 4 goes into 17 how many times? 4 times. So that's 16. My remainder is 1, okay? So I can write this, I to the 17th. So I to the 17th is going to be I to the 4th. I to the 4th, how many times? 4. That gives me 16 i's. How many more do I need? 1. That's my remainder right there, okay? Okay? So what is I to the 4th? 1. What's 1 to the 4th? 1. What's 1 times I? Yeah, that number is I, okay? So if you can organize in powers of 4, then it makes it a lot simpler to evaluate this. Okay. I to the 234th, okay? It feels hard because the number is bigger, but all I need to do is to take 234 and I need to divide it by 4. So when I divide this number by 4, I get what? 5. 5 times 4, that's 20. 4 would go into 34, what, 8 times? Right? Is that correct? So 4 times 58 is 232, 234, okay. So that means that I to the 234 can be written as I to the 4th to what power? 58, okay. That gives me how many i's? 232. So how many are left? 2. Okay. So what's I to the 4th? 1. What's 1 to the 58th? 1, okay. So this whole number, the reason I organize this as I to the 4th, because that makes that number always what? 1, okay. That makes it real easy. All I'm left with is I squared. What is I squared? Negative 1. This thing is negative 1, okay. So what you should be able to do is you should be able to divide these things by 4, and whatever your remainder is, That's the power of I this is equivalent to. So 84, what happens when you divide 83? When you divide 4 into 83, okay, this goes in there 2 times. That gives me what, 8? And my remainder is what? Remainder is 3, okay? So this means that I can write, oh, sorry, this is goes in there 20 times, okay? So I can write this as I to the 4th to the 20th power. How many is that? Well, how many power? It's 80, so I've left with what? 3 of them, okay? So I to the 4th is 1, 1 to the 20th is 1. This is just I cubed, okay? So this answer is I cubed. Now what if you don't remember what I cubed was? How can you figure that out? I cubed is I squared times what? Okay. What's I squared? -1. What's -1 times I? Yeah. This answer is -I. Okay. So what you can do is what we're always coming up with is whatever when I divide by 4, whatever my remainder is, it's I to that power. Okay. Let's take 50. What happens when you divide 4 into 50? So 4 goes into there what, 1 time? So that leaves you with this. So that's 12. That's 48. Sorry, that's 8. What's my remainder here? 2. Okay. If my remainder is 2, then this becomes, that's I squared. Okay. You divide it by 4, and you can go through this, divide it by 4, and then write it as I to the 4th times 20th I cubed. But your answer is going to be I to whatever your remainder is. Okay. If I'm dividing by 4, what kind of numbers do I get for my remainder? Can I get 7 as a remainder? No. What numbers do I get? 0, 1, 2, or 3. There are only 4 numbers that I get. So again, if you're not seeing this, this is, according to this division, this is I to the 4th. And it looks like I've got 12 of those. That gives me 48. How many are left? There are 2. Okay, this is always going to be 1. So what is I squared? -1. Okay. So all you really have to do is divide this number by 4, and then I to the remainder is your answer. So what happens when you divide 4 into 121? It goes into there 3 times. So it goes in there what? 30. And my remainder is 1. So this is what? Yeah. This is I because my remainder is 1. So this is just I to the 1. Okay. What about I to the 180? What is that one then? So 4 goes into 180. Goes into there what? 4 times. That's 16. Leave you 20. 4 go into there what? 5 times. What's the remainder? 0. So this is I to the 0. What's anything to the 0 power? 1. Okay. Does everyone see what we're doing there? So if I give you I to some ungodly number, all you have to do is divide that number by 4, and you get a remainder. I to that number is your answer, okay? And then you have to be able to know if your remainder is 0, I to the 0 is 1. If your remainder is 1, I to the 1 is I. If your remainder is 2, I squared is what? -1. If your remainder is 3, I cubed is, and if you don't remember this, I cubed is I squared times I. What's I squared? -1. I squared is -1, so this is -I. What's I to the 4th? It's 1, okay? So if you can just work through those numbers, you can work through any number, okay? So real quick before we move on, just to see if you guys can do it, what is I to the 573rd power? gosh. What do you get? I. Okay. So all you have to do is divide 4 into 573. So it goes into there 1 time. That's 1. Bring down to 7. It goes in there 4 times. 16. That leaves you 1. And bring down the 3. Goes into there 4 times. That's 12. Leaves you 1. My remainder is 1. Okay. So this is I to the 573 is I to the 4th times 144 times I to the 1st power, which is just I. Okay. Pardon me? You're right. So 4 times it's 43. Thank you for catching that. So that's 143, and that makes this a 143 as well. So basically, if you can just divide the number by 4, get a remainder, I to that number is going to be your answer. Okay. Multiplying complex numbers. Okay. This one gets a little bit more involved. Okay. But what if these weren't complex numbers? What if this was just x plus 2 times x minus 3 and you were in middle school? What would you do? You in fact, there we go. You learned the word FOIL. Okay. Same thing here. So it's already factored. So to FOIL, what does FOIL mean? What does it stand for? First, outside, inside, last. Okay, so do you do the drawing things or? Okay. So if I multiply these first 2 numbers together, what do I get? 8. If I multiply the outside numbers, what's 2 times negative 5i? Negative 10i. Okay. If I multiply the inside numbers, what is 3i times 4? 12i. And then if I multiply the last numbers together, what is 3i times negative 5i? Negative 15i squared. Okay? Does everyone see that? Now, do you think I'll leave that as my answer? I want it to be a complex number that looks like a plus bi. So the first thing I can do, what can I do with these 2 things? That's what? Let's go with positive 2i. So this is 8 plus 2i minus 15i squared. Anytime you see I squared, bells should go off in your head. What kind of number is I squared? Negative 1. Okay. So this is 8 plus 2i minus 15 times negative 1. What's negative 15 times negative 1? Yeah, so this is 8 plus 2i plus 15. So what is that? 23 plus 2i. And there we go. So a little bit, this is harder, right? Multiplying is a little bit more involved than adding. You just have to go back to what you learned about when you multiply binomials, okay? And then you have to know that I squared is negative 1, that simplification, okay? Let's look at the next one. So, and I want it to be in the form of a complex number, which is a plus bi. What's the real part of that number? 23, and the imaginary part is 2i, okay? Let's look at the next guy. So I'm going to multiply these together. So when I multiply the first 2 terms together, what do I get? 4. When I multiply the outside terms, what do I get? Minus 2i. When I multiply the inside terms, what do I get? 2i. When I multiply the last terms together, I get what? Minus I squared. Okay. What happens with this 2i and minus 2i? That's 0. So this is 4 minus, what's I squared? Negative 1. What is this number? This is 5. Okay. So I think this is pretty remarkable. You took two complex numbers and you multiplied them together and you got what kind of number? A real number, okay? So these were two complex numbers. They multiply together and your answer is 5. It is a real number, okay? Let's look at the next one. How do you think I multiply this? What do? I distribute. So what happens when I multiply I times 3? Yeah, you want to get in the habit of writing 3i, not I3, okay? Let's just do that. You don't ever write like x2, you write 2x, okay? So 3i, and then what happens when you multiply I times 2i? Yeah, plus 2i squared. And then you want bells going off in your head. Anytime you see I squared is what? -1. So this is 3i plus 2 times -1. If I write this in the form a plus bi, the real part first, what's the real part of this number? Yeah, -2 plus 3i. That's the answer for this guy. And it looks like the last one of the day here. So multiplying numbers, what do? 4 times 2 is what? 8. That's the first terms. What happens when I multiply the outside terms here? Yeah, minus 24i. And then when I multiply the inside terms, 6i. When I multiply the last terms, I get what? -18i squared. Okay, so this gives me 8. What's -24i plus 6i? So that's what, -18i? And then minus 18 times what? Times -1. So this is 8 minus 18i plus 18. What's 8 plus 18? 26. This is 26 minus 18i. Okay. Okay, pretty good with that.